welcome back to another video. So this is the fourth part of our NIDS series, and in this video we are going to be introducing a YARA based rule matching to filter our network traffic, or at least do some pattern matching on the network capture files, the PCAP files we have captured for our HTTP streams and TCP streams. So let's get on with it. We will be using the YARA Python library, so let me set it up. Everyone, so this is the YARA Python library. If you do not have it installed, okay, so I currently have it installed, so if I import YARA, it doesn't show any errors. If you don't have it installed, just give install YARA Python, whatever name is, and yeah, it should install for you. I already have it installed, so I'm going to continue for that. Okay, so this is the official GitHub of the YARA Python module. So we have to, for those of you who don't know what YARA is, so YARA is basically the industry standard for pattern matching. It is the industry standard tool. We can execute pattern matching on hex strings, just in general strings, or files, on network traffic in our case. So we are going to be using this. It is primarily used in malware research, as you can see, but we can also use it in other cases. But we can, as we will see further on in this video, we will be using it to scan for P file headers, for some malware signatures, and for some malicious IPs and domain names. So anyway, let's get on with our code here. I'm going to be holding the slides, so it's going to be a bit longer, this video, but the other parts, but bear with me. It shouldn't be too long. So first we have to import YARA, and since we are going to be doing a lot of file handling, we already have OS imported, so I'm just going to import a blob. So that's another module for file handling and directory operations. So with that done, let's first run our program. So Python custom IDS, and let's see where we can start. Okay, so I just tried that there, yeah. So I think I hit something before, yeah. So this is okay. So, okay, it should start now. Okay, the first thing we could do is update the GUI, so we can add a button to filter out packets using YARA rules, and then maybe another response and level here to show the packets and streams, HTTP streams filtered out by YARA. So let's add the GUI first, and then maybe get into the rest of it. Okay, so let's see. So first thing we do have to add is another button there. So I'm just going to copy this one, copy it, and paste it. We rename it to something like YARA filter string button. And we do need to change the level of that, so let's do YARA filter streams. Okay, next we do need another level right here, so copy that, paste description font, those things can be the same. So this we can rename to YARA flagged streams, right? So next we need to add a list box to that, so we can just copy this one as well, Control C, and we paste it. So let's go. Values, we don't need to create a new list for this. Let's okay, what will we call it? This language. So we can convert YARA, so flagged, and since we will be saving this YARA flagged streams in different files, so file names, and okay, so let's have it YARA flagged streams. So our GUI should be updated. We do have to create this list though, so let's just initialize it up here, and then we can check our GUI has been updated. If it has been updated, then we can proceed. Let's check it. Should be updated. Yeah, let's see. Okay, so we have got a YARA filter streams button, we have got here flag streams. So now for the real part, we do have to give the YARA code. So okay. So first, one thing we are going to use. Okay, so let's check. Okay, so here basically we need to compile the rules. We can compile it from our rules file, which we are going to do, and then we have to do rule.match with the data and you can say rules. So we can compile the rules in a file and compile from there, and we are going to need to do a rule.match for every packet stream. So it will be better if we divide the packet streams, means the whole pickup capture file, network capture files into each stream. If each stream has a file, it will be much easier to process. So here is where a new tool called TCP Flow 64 will be coming to use. So we don't think it's working for now. Okay. So for those of you that are wondering what it is, so what is TCP Flow 64? Okay. So basically a program that captures data transmitted as part of the TCP connections and stores it in a way that is convenient for protocol analysis. So basically what it does is if we pass a pcap file to it, it extracts all the streams from it for our purposes, and it will store each stream as a file of its own with its own file name. So we can refer to each stream as a file, and we can use that file to match against YARA rules, and we will have to match each of those files. So that's basically why I included the glob library right there. So right now let us begin. Let us go down to the top. We can begin with the scan function first. So these are the events. So okay, let me add the functions from down here. So first function should be div here, let's have here scan rate. So this will be we can pass a scan file to it, and we can pass the rules to it, maybe yes, to check against, and basically what it does. So we can create a matches list. So each match to each rule will be stored in this list. So we can use OS to check if the file exists. So if os.path dot this file, we can view, right? Or we can see if the file actually has any size. So os.path dot get size we can do. So scan file, and if that file actually contains some data, so file size is greater than 0, we check it against the rules. So rules.match, right? Again for match, and we execute, we pass the data of scan file, right? So for each match, we want to store the match in matches. So matches dot append. Okay, so we are going to store it as a dictionary for now on. So there will be the rule name, right? So this will be the name of the rule, and we can include match.rule. This will store the rule name, so we can identify what rule has been matched, and next we can store maybe the meta, right? So the metadata of the rule. We can store various types of information about the rule in the meta itself. So match.meta. Yeah. So this should do well enough. I think there is something wrong with it. Is there? Doesn't seem so. It is. Okay, so we have appended the two matches. So now we return the matches, and so there we have our basic scan function, right? Yeah, we return the matches. Now for a bit of the complicated part. So first, what we do have to do is we are actually going to scan the HTTP string files and the TCP string files that are going to be stored in the temp directory. So if those files have not been created, so first what we need to do is create those files. So let's scroll down below, and we can see how those files do get created, right? So the HTTP string files are just created by the read HTTP function we called. So that does not need any parameters. However, if we need to show the TCP, if we need to actually capture the TCP streams, we do need to pass a window as a parameter, right? So let's see. Here we have named our button. Let's go up to our, yeah. So we need to program an event for if when this button YARA filter streams is clicked. So if event is equal to this, we can just copy it, right? stop it and go down there. So we declare an event for it. So maybe we define a function, right? So each time that event is called, we execute that function. So yeah, so let's define a function for that. Event and YARA plant, right? So YARA plant and um, yeah, maybe the button is clicked. So other YARA filters. Yeah, YARA filter streams. So if you do wonder why I'm looking to my right, so I do have my notes stored down there. So I already have the program uploaded to GitHub, and just for the sake of video, I am going through it. So I may be looking to my right quite often. So my notes are down there on the monitors anyway. So we do need to pass the window for the TCP files. If we need to load the TCP streams, pickup files, so we do need to pass the window for that. So let's check if those files exist, and if not, let's load those files. So if not, first pass the this file. So to check if the file exists, first we can check temp and TCP stream read.pickup. So that's the TCP stream file. If that does not exist, we can call on the function that from TCP streams, and we do need to pass our window to it. So that's the same window as this one. So yeah, that is great. So now we need to check for our HTTP stream file. So if not, same thing was path this file. So we need to check for HTTP stream file. So temp HTTP stream.pickup. So if this file does not exist, all we need to do is just load HTTP open, read HTTP. So HTTP, if you call that. So we have just checked and confirmed if our pickup files are there, because we will be executing our YARA based searches on these pickup files. Okay, so that should be good. Okay, we do need to access the list where we are storing our YARA flagged file names. So we can declare that as global right now. So YARA flagged file names, and just for the sake of it, since every time we are executing this function, these YARA searches are going to be executed from the beginning, so we can just clear out this. So YARA flagged file names, we can clear it at the beginning of every YARA based file check. So we do need to dump the files, right? So let's see. Okay, so that should be okay. So we do need somewhere where to dump the files. Okay, so for now, let's see. We are going to be using TCP Flow 64. Okay, so TCP Flow 64. If you do want to download it, you can download it from Digital Copra. Just a simple Google search will work. You can download the latest one if you're using Windows 64. So 64-bit Windows. You can download the exe. I do have it downloaded right here. So downloads. Yes, so I do have it downloaded, and so let's move it on to the screen, and we can move it to its Python name. So we have it within our reach. Let's rename it to something a bit more convenient. So here's that. So we do have TCP Flow 64. Now, just to demonstrate a bit on how this works. So let's see our filter streams, right? Okay. So let's capture some traffic, generate HTTP streams and TCP streams pcap, so I can demonstrate how that TCP Flow 64 works. So let's start cap. Let's just refresh this page. We are start downloading it and then cancel it. Yeah, download it. We are downloading and then we are canceling. Or maybe okay. So we have downloaded anyway. So that should be enough traffic for yes. That is enough traffic. So start cap. We load TCP streams. Let it load. And then we load HTTP streams. Anyone should do, but let's load both for our sake. Okay, so let's load our HTTP streams too, and then yeah, once those have been loaded, we can quit this. So now if we go to our temp, okay, so we do have two packet capture files, and now let's take a look at what TCP flow 64 does. So I'm going to clear this out. We do have TCP flow 64 here, so let's execute it. So TCP flow 64. Now we need to specify a few arguments: tag A and tag R. Tag A for splitting the files up, and tag R for reading from a pcap file. So right now we are reading from, let's see, from here temp, and what is it? HTTP TCP string read.pcap some TCPs read.pcap, and we can also specify an output directory. So let's create a directory for now, and let's temp. Let's new directory, new folder. Okay. Let's rename it to something. So TCP flow down with. So output we can do to temp TCP flow down. So that should work. Okay, so now this is executed. We can see, so every HTTP or TCP streams in this case has been saved as an individual file. So all we now need to do is check those files against our YARA rules using the rules.match function, and then we can generate a report based on that. So anyway, so this is how it's gonna work, and let me write it down as a comment. So okay, so comment it out right now. So we do need tag A, not capital small f. We do need tag R to read from TCP, and we need tag O to output to an output directory. So let us first specify the output directory. I think that should work. Okay, so am I missing anything? I don't think so. Just let me check if you're missing anything, or if you're not, then we can proceed. Okay. So let's declare the output directory in the beginning, where all our all our variables have been initialized. So here, okay. So let's create. Okay, so let's this is nothing but just the base directory to TCP flow dump. So temp and TCP flow dump. We will be reading from this directory for matching to our YARA rules, and we will be also putting our TCP flow 64 files to this directory. So it's best if we set a base path for it, and then we can refer to that time and again when we need to. Anyways, returning to our YARA filter streams. So let's go back down. Okay, YARA filter streams. So yes, so here we are. So we can we do need to declare that path as a global, so we can access it. So global, I think ring file. So okay, now we need to now we do need to create a list of all the files in the directory if we are going to filter it with YARA, right? So we can do dump files. So dump files is equal to, okay, here is where globe.globe is going to come to use. So I'm going to demonstrate this, but just let me write this down first. Okay, so asterisks. So anyways, we can demonstrate this if we want. So Python, we can import globe. So if we execute globe.globe for our TCP flow dump directory, so that is temp and TCP flow dump, and you can see we have added an asterisk to that. If we execute it, this returns what if we print it actually? Okay, let's see, for file name maybe, for file name maybe print line, right? Okay, TCP flow dump. Okay, it is supposed to be showing a lot of files anyways. Maybe okay, this is supposed to be showing a list of the files anyways. We can get back to that later on, maybe continue here. I don't know why it is not showing anyways. If we now want to remove all those files because we want to clear from clear everything from that TCP flow directory and then dump the new files using TCP flow 64. So for file in dump files, maybe os dot remove the file. So now if we do execute it, let's bind this to a button, or maybe yeah, sure, we can bind this function to the YARA filters button. Okay, so we can go to the very end and we can add an event for this one. So let me check what I have named it. What was the button name? Okay, yeah, okay, YARA filters button, right? So if event is equal to equals that's YARA filters streams, but just check if this exists. Okay, I think I have named it as stream, not streams. Let's just check. YARA filter stream. Check. Okay, 2 of 2. Okay, so maybe rename that to streams and go to that and rename this to streams too, because there will be more than one stream. So just make grammatically correct. So if we call YARA filter streams, I think yeah, we can close this. So YARA filter streams, and we don't need to pass in the window to that. So we can just copy this for when we are not capturing 2. So right here, this indentation bit. Alright, so now if we do execute this function, what is supposed to happen is it will read all the files in the base path and it will hopefully remove all those files. So let's try running this and click that button and see if our files are being removed. So start the custom IDs. We can see the files are here. Let's see. And I can move this to the side and move this here. So now if we do click this button, hopefully the files will all be deleted. Let's check. Okay, so the files have all been cleared. We are reading the files and we are being able to clear it. So that works. Now we do have to execute the TCP flow dump command, right? So let's see. Okay, we can use a process. I think we have it imported, but let me just check once. Subprocess, do we? Yeah, so we have subprocess, so we can execute a subprocess.call, right? So subprocess.call, and we need to pass in the function to it. So we are executing TCP flow 64.exe. We are executing it with A and tag R. First TCP stream.pcap, and we can output it to that TCP flow dump directory. So TCP flow dump that, yeah, and just to see if there are any errors, we can set shell equals true. So what that will do is show us if there have been any errors to this, and let me just check if I'm recording. Yeah, we're still recording. So that will check for that will show us any errors that may or may not pop up. So we do need to do that once more. So we copy that, and what we need to do is that we need to get those files for the HTTP streams. So HTTP stream read. So yeah, HTTP stream read that we got. So we are getting the files for both of those right now. So we do have those pcaps. So right now, if we execute this function by clicking that button, we should be able to see all the files pop up. So let's check for that. Let's see if that's working, and then we can proceed. TCP flow down. Okay, so let the window come up. So right now, if we click that button, yeah, so I had it clicked, so all the files have shown up. Just in case there was delete those once more, and yeah. So now if I click this, both those pcap files will be the streams in those pcap files will be split into all these files. So each file here is a TCP or HTTP stream, and we can check each of those files against our YARA rules. So we don't need to delete them for now, because each time the function is executed, they do delete themselves, as we see here. So yeah, we can move on. Yeah. Now to something a bit more interesting, we can write our first YARA rule. So just let us check the manual on how to write a YARA rule. So yeah, rule and rule name, right? So under that we can use strings and conditions. So we can be checking for strings, right? So let's open up the YARA rules. Just give me a second. All right. So okay, let's do this a bit. So let's create our own YARA rules for now. So we can create a directory here. So new folder and maybe YARA rules, and under that maybe create a rule files. In file we can have this rules1.yara. So that should do. So okay, so we can check. Let's see. If you want to check for exes always mostly have the string. This program cannot be run in DOS mode at the beginning, along with the MZ initials in the beginning. So we can check for that. So we name it PE. Yeah, P file. P is portable executable. So we don't know. So P file header, and we do need to give a third bracket to it. So that's the rule. We specify it with rules, so we can specify strings for that. So strings, maybe okay. So just like declaring variables, we are declaring strings here. So str1, and maybe we declare it as, we do need to declare it within double quotes. So this program cannot be run in just as much. This program cannot be run in DOS mode. If some of you are wondering what this string does and why we should be checking for the string, so if we do a quick Google search with the term portable executable. Okay, so the MS-DOS stub, which is this particular string, is a valid application that runs under MS-DOS. So it is best at the front of the exe image. So at the front or at the beginning of every exe file, we can find this particular string. This program cannot be run in DOS mode. So if we do check for that string, we can be pretty sure that we have found an exe file, or at least a file that cannot be run in DOS mode. So we can check for that. So that is the string, and to check for that, we need to declare the condition. So there is one condition, that is any of them. This is a particular keyword specific to the YARA language, let's say, and we can, let's say, declare some for it, maybe a description. Checks for, let's say, portable executable files, and let's add an author to cybersec adventures. Let's do that. Okay, so this is our first YARA rule, and we can use this to check against our traffic. So let's go back to custom IDS.py, and let's compile these rules. As we saw earlier on, we do need to compile these rules before we can use them to check for files. So YARA file we can declare is equal to, we need to specify the path to that. So YARA rules, and then rules1.yara. So that should work. And now we need to compile that. So YARA rules is equal to, we have imported YARA, so YARA.compile, and we pass to that the YARA file. We do not need to pass a file header, just the file path, and it will do the rest for us. We'll compile the rules. Now let's initiate a counter to see how many matches we have found. So match count. We can start from 1 and go from there on. We can store the results in a list, and we can store them maybe as a text form also, just in case. So anyways, so now what we do need to do is check each of these streams, each of these files against our YARA rule. So we do need to iterate through each of them, so we can use os.list directories. So for request, let's say os.list directory, and we can pass in the directory to that, which is the rec file of base. So for every request, we need to scan it. So we need to pass it through our YARA scan function, to which we need to pass the scan file and the rules. So result is equal to, let's say, YARA scan. We need to first pass the file, so we can do os.path.join to join into the rec file path base. And to that we will join the file name, which is rec. So we pass the file to our YARA scan function, and then we pass the rules, which is the rules we have compiled, YARA rules. So let's see if we do get back any results. We do want to process them. So the results will be a list of all the matches we have found, right? So because YARA scan returns matches, so that's a list. So for match rest, for each match we can do something. So each match is a dictionary, so maybe we can pre-print that for our debugging purposes right now. And then okay, so we can import preprint. Preprint is just basically a way to print dictionaries in a more readable format, dictionaries and JSONs. Anyways, so we can preprint the match. So we'll print okay, so we can preprint and we can print in the match. So that will print the dictionary, and we can append the match to our results. So results append, and we can append the match. So we do need to it will be better if we append it as a dictionary. So the rule which matched will be against match name. So match name will be the name of the rule which has been matched, and then I think we don't need to append anything else for now. We can do the same for results. So results text, and we can do plus equals. So we can include the match count, and then to that add maybe full stop and make it pretty. So and to that add the string something match with the name. That should do fine. Okay, so let's add a new line to that as well, so they don't all print on the same line. Okay, so we have got results.text, and then we increase the match count by 1. So that should do. Now for each rec file, yes, so for match, okay, if the file, okay, the file equals to report.xml, because we don't want to check the report.xml file. So the report.xml file is always generated for TCP flow, so we don't need to check that. We just need to check each individual stream. So excluding that, for each file we can append to YARA flag. Okay, so we don't need to display the YARA flagged files on our GUI window, so we need to update that list. So what we need to do is append to that. Let's append the rule name first. So match, we can append the name to that, and then maybe add a separator, and it can be anything. I'm just using 3 columns, and to that we can add maybe the file name. So we can just split by the separator and access the file name whenever we want, but we do need to show the rule name because that's the most important thing. After that comes the actual file itself. So first of all, in our GUI we do need to see that what rule has matched and if it's a critical rule. So that comes first, and then after that comes the file of this packet stream itself. So anyways, we do open that, and now once we have gone through each file, we can write our results to let's say a file. So that's a YARA result. So we'll open, and we can go okay, so let's name it something, YARA res.text, and we will open it in write mode. So it will write so as this file, and we will write the text to it. So the text is result text, right? So we write the result text to it, and then maybe print each file that has been matched to the console, right? So for filing YARA flagged file names, maybe we print the file that has been matched, or the TCP string or HTTP string that has been matched to the console for now, just for debugging purposes, in case our window does not respond or does not show or anything like that. Finally, we do have to update our window, the list box with the list of newly YARA flagged file names. So window, I think I named it YARA flagged streams, right? And I hope that's what I named the list box. Let's check. Okay, YARA flagged streams, right? With dashes. So that's what I did damage. So window, and we do need to update that. So update, and we pass in the YARA flagged file names. Okay. How long has it been in this video? It has been 42 minutes, whatever. Maybe, hopefully, within another 40 minutes, we can wrap this whole feature up. And then we just need to return this. Okay. So, return. So now we have returned this. Hopefully, we can scan the files for the headers. So I have my local server here. I have an exe file stored there, which we can download, and then we can capture the download and see if there are flags. So if you run custom IDs, we can go to my local server. So it's running on 192.168.0.80. So we do have an exe file here. Now, before we download it, we need to start the capture. So we download it. Yeah, we do keep. So it has been downloaded. Let's let the download finish. So hopefully it finishes quickly. Okay, so it has finished. Now we can stop the capture, and then we refresh our TCP and HTTP streams. Let's see what comes up. And then if we filter those streams using YARA filter, okay, so we do have an error. Let's see. Okay, YARA file is not defined. Okay, so that will be YARA file. Okay, so okay, yeah, right here. So YARA file, that will be the one from which it compiles the rules. Our TCP and HTTP stream files should still be the same right here under temp. So we don't need to capture the download again. We can just run YARA filter streams. So okay, let's check what other error is there. YARA scan is not defined. So I think I defined it, right? Okay, I added an extra S to that. So remove that. Hopefully this time it will run. So let's check. There are many of these small errors, so we have to go around them. Yeah, let's see if it filters. Okay, now what? Right must be string and not list. Okay, so result text is a list apparently, which I can't believe why. Okay, so that's a list that needs to be a string. Let's check once more. So let's let it start up. Now if we try to stream what now list box has no attribute, but okay, so that will be update, not page. That will be update. Let's see now what else we have messed up. There shouldn't be anything. Okay, so let's filter streams. It should show down here. Okay, it does not show anything. It should show. Okay, so it does not find anything. Let's maybe add a few more rules to it. So change rules.yara. Maybe if we modify the rules a bit, we can see. Okay, so there are a few hex values we can check for, but this program cannot be run in DOS mode. Should work. Let's maybe let's see where we are messing up. So we are not detecting it at all. Let's see. Let's check for ASCII maybe. So this is a hex value. So let's see what hex. Okay, so maybe we do need to pass it as hex. So I'm not going to write that down right now. I do have the hex value for this, so check for the hex value after yields results. So there should be some way to copy it, right? So maybe use share mouse for that. Share. Okay, so share mouse should be running. Okay, so share mouse is running. We copy that, bring that here. Let's see. Let's modify our YARA rules and let's add x1, right? So x1 equals this in ASCII. Right? So let's check now and see if we do find something of interest. Let's execute that and let's see. Okay, so if we execute YARA filter streams, we still don't find anything. We need to wonder why. Maybe we didn't capture it quite right. Let's see. Maybe if we do refresh the pickup files, we could have it. I do have the pickup files backed up here, so let's check that. So yeah, temp. Okay, so we don't have it backed up here. Let's try to capture the download once more and see what we get, because I don't think it downloaded at all. If we check in our downloads folder, make sure that it is indeed deleted. Okay, so let's delete this, delete, and then start cap, right? Go to Google, download exe file from the HTTP site, and there we should have it. Stop. Oh no, stop cap. We should have it down here somewhere. I saw it flash right. So what was the first message we received? It should be. Let's check. Okay, it should be somewhere in there. Let's load HTTP streams and TCP streams and see what we get. Yeah, so TCP streams have been loaded. I don't want to check each one of this one by hand. Anyways, let's apply the YARA filter streams to check it. It still does not show up here. Okay, let's see. What can our mistake be? Maybe if we check with DOS or close it. Maybe it's downloading cache, so it's not capturing the exe file download. So let me just stop my server and then restart my server, so it does actually download the file instead of downloading in cache. Okay, let's start my server up once more. I'm going to start up Google once more just so that. So if we try to download it once more, we go to that page, we restart it once. Let's see. Let's try to capture it once again and see if we do get the exe file to capture. So start the capture. We try to download it. And we keep it. Okay, so it's been downloaded instantaneously. Okay, hopefully it captured something. Let's see. Let's load streams and then apply the filter. Okay, so it still does not flag. I'm not entirely sure why, but just to check if our YARA filter is working, we can, okay, so BE9, we can include that as a string and see if the YARA filter is working, right? So we can use that as a rule. So BE9 is being used, so maybe $A1 BE9. Maybe we use that and see if our YARA filter is actually working. I don't know why it is not capturing the exe file transaction anyways, so it should capture something. Okay, So now that it does capture, yeah, so it is finding a B9 in there. So the YARA filter is working, but results text, okay, local variable reference with for us. What is the local variable? Results text, match count, wow, that is local variable. So what is it? Result text match count. Maybe we hold on. Maybe we put that up for now and let's check once more if it is detecting that B9 string in our network traffic. So we run that. Okay, so B file headers. It is indeed picking up that B9. So our YARA filter is working. I don't know why the exe download is not being captured. Maybe if I upload a different exe to my server and then try to get that, it should work. Let's see what other exe have we got. This is an exe, right? No, that's an I. Maybe we have got an exe here stored here. Okay, so we do have an exe. We can take that. We can place it in our server, right? So we do have an exe that I have not downloaded before, so it shouldn't be stored in cache or anything like that. So we should be able to capture a real file download and then run the p header on that. So I am removing the B9 rule for now to check if it is indeed filtering the p headers, right? So if we run that once more and try to capture our file download, let's see. It runs, yes, it runs. So we start the capture and we download our file retrieval.exe and we keep it. Okay, so this also seems to be in cache, but anyways, it is done. We are still capturing. Let's see, let's stop the capture, or maybe let it finish for a while because it is getting data from my server. So let's see. Let's wait for it to stop and then we can run the p file header check. Hopefully it has captured the file download. It seems that I also do have this one downloaded as well, so I do need a big exe file. So we can check this p header filter thing. Anyways, let it finish and let me see if I can pull out an exe file and we can check the YARA best filter on that. And once that is done, we can just program a simple display to display the packet string of our from if an item is clicked from our YARA flagged strings. So let's check for a bigger exe file. Let me see if I do have one. I do have the NASM installer. Let's see if that gets captured. Let's see, control V that to the demo folder. So here, let's see if it catches that. Let me just check if our latest download has been captured. So load HTTP strings and maybe load TCP strings and then run the filter on it. There has been a lot of packets of TCP strings. Let's see. So, okay, it is showing that retriever in one of our packets. So hopefully it has captured the exe file transfer. Let's see if here it or something. Okay, so we do see that we have captured the file download and it is finding p headers in 4 packet streams. So that's what it took to download our file from a local server. So we are capturing the exe file download and YARA is actually filtering out that capture based on the rules we have described. So now we need a way to see what those packet streams actually contain. So let's go back to my notes here a bit. Okay, so I do have my notes. So we'll just write one more function. So if an item is clicked from that, we will just show it. So maybe show YARA that, and we I don't think we so we need to pass the string data to it. And let's just copy paste this one from one of the other show functions, right? So let's look for a show function. Show HTTP to stream. Now just let's shorter show maybe. But okay, so yeah, this will do just fine. Just fine. Okay. Control C, and we can paste that down there. Show in our show YARA flagged functions, right? So let's go down. Okay, not right here. Should to find. We have the indentation. We need to replace this with the string data, and maybe replace this with disciplining text. Let's replace that with YARA flagged text and HTTP2 stream. Instead, we have that to YARA flagged stream. So now once we click something on our list box, let's see what that event is called. We can get the data, we can read the data, and then we can show it here. So let's see what my list box is called. Okay, so YARA flagged streams, if that's an event, we show it. Right, so we need to do this both while packets are being captured or once it is stopped. So let's just review my notes here a little bit. Okay, so if event equals, so we enter that YARA streams. So if one of the items YARA flag strings has been clicked, we do want to show it. We need the file name from that. So YARA flag stream. Let's see. Dat. Okay, so is equal to so that will be values, and in values we need the event, and from that the first one, because only one has been clicked, we are not selecting multiple of them, so 0 into 5, and then I think that is the data. So we need to pass it to our flag selected, right? So let me check just once. Okay, so we do need to filter that bit, so let's pass it to a new function. Let's call the new function YARA flag selected. So what we do once the YARA flag has been selected, so that YARA, so that's the event, so event that, and it has been one of those flag streams has been selected. We do need to show it now. We need the stream that here. Okay, not the stream that, we do need the file name here. So file name that is unedited. So the unedited file name. Now we extract the YARA file name from that. So YARA file name is that file name unedited, and we split it using the separator we mentioned earlier, which is the triple colon. You can use anything here, just make sure they are same in both the places, and we specify index 1 because the file name is later on, and the rule name is the 0th index once we split. So we get the first index, and file path we do OS path join, so OS path join, and then we get the file path base. So we can declare it global, but once it does not find it in a local scope, it will automatically refer to the global namespace and find the path. So we need to join it with the YARA file name, right? So we have got the whole file path for that, and now we need to read the data. So this is the file path for the flagged stream, that particular stream. So we need to read that data. So with open file path, so we will read it, open it with read permissions, and now one thing, many times these files contain many characters which are not decodable or readable. So for that we will just ignore the errors raised by that for now, and we open it as YARA flagged file, and the file that, so the string that flagged file that, and we need to read that. So YARA flagged file, and we need to read that. If we do not specify the ignores error above, so if there is some Unicode character it can't decode, so it will throw an error, and that whole function will just terminate. So that's why we have to while trying to read. So that's why we just threw the error there, and now we need to show the YARA flag, right? And we need to pass the data to it. So YARA flagged file that, something about that. So now theoretically, once we click on one of those, it should show us the HTTP string that has been flagged. So let's see, let's try to run it again. Since we already have it captured, the HTTP streams and TCP streams, we do not need to capture it again and then load it again. We can just do YARA filter streams, and we already have those. Now if we click this, hopefully another window opens, and we can see, okay, so it is not opening, and I think I know exactly why, because yeah, I have specified, okay, this one, so I have not specified the new function at all. So the new function is event YARA flag selector. So we need to call the event YARA flag selector. We need to pass in the string that to that. And what we do need to do, not only that, we need to declare this event even when we are not capturing pattern. So right here, we need to declare it true, and let's fix the indentation of it. Indentation is fixed. So hopefully now it will work as it is supposed to. Once we click on the YARA flag TCP HTTP stream, it should show what stream has been flagged. So if we click on it, we can see, yes, so it's an application update stream. We can clearly see that this program cannot be run in DOS mode, that the line is there. We can also, for portable executable files, we can also use this MZ header, because that is also present in all portable executable files or .exe files that are meant to be run on Windows 7. So we can use both those, the DOS mode string or the MZ string, to identify exe files. Now, YARA rules can be used to identify malwares, various strings, anything. Basically, anything we have to do pattern matching. Anything we have to apply a pattern matching algorithm, YARA can help us there. So malwares, suspicious websites, domain names, maybe IP addresses. Maybe we can declare another rule here, maybe, and in that rule we can put IP addresses, restricted IP addresses, or domain names as a string, or and we can put the condition in any one of them, and then if our computer or our system is communicating with any of those IP addresses or domain names, then they will be flagged under the YARA rules. So we can create a rule for that later on. There are many lists from which we can draw those IP addresses and then specify them here. So I'm not going to do that in this video, but yeah, we can use YARA for a lot of things. This is just the basic application of detecting whether there is an exe file being downloaded, but we can basically use it to pattern match anything. So in later videos, I'm going to apply this feature so that it can apply YARA rules and flag packets while we are capturing packet live, not just from the HTTP stream or the TCP stream, but from it all. And we will design it so that it does not have to apply the filter on the HTTP or TCP streams from PCAP files, but it can directly get the data from the live packet capture, and instead of storing it and then analyzing it, we can analyze it live. But that's for another video. Today we have completed what we aim for, that is applying YARA based filtering or YARA based rule matching to PCAP files that stores the streams we have captured. So that's it for today. So goodbye. See you in the next video. Thank you for watching.